So each compressor blade is actually an airfoil. It's subject to the same aerodynamic principles as a wing or even a propeller. Just like a wing can stall and lose lift when the maximum angle of attack is exceeded, the same thing can happen to a compressor blade, or even, the entire stage or stages of the compressor. When a single compressor blade or stage stalls, it's said to have stalled. But when the entire compressor stalls, that's what we call a surge. Compressors can experience stall or surge on the ground, like when a high wind suddenly blows across the engine inlet duct. The same thing can happen in flight too. The distortion of the inlet airflow can change the angle at which air strikes the compressor blades, causing a stall or surge. At other times during flight, things like icing, a rapid throttle movement, rapid maneuver, or even a fuel governor malfunction might cause a stall or surge. Any deterioration of blade shape due to erosion, buildup of deposits, or blade damage contributes to the problem. Airflow control systems must function as designed to provide the compressor with a steady flow of air at the designed angle so the compressor can function properly. Failure of the variable inlet guide vanes, variable stator vanes, or even a compressor bleed system malfunction can all contribute to a stall or surge. The technician may recognize a compressor stall or surge during a ground run-up by hearing abnormal noises, rumbling or moaning, or just a bang. This, accompanied by rapid changes in values indicated for RPM, EGT, and EPR, are signs of compressor stall or surge. Poor throttle response is another sign. The effects of stall or surge are detrimental to the engine and, moreover, to engine life. Changes in material properties and fatigue due to shock loading of internal engine components occur. High EGT spikes during a surge reflect high turbine section temperatures that may exceed design capabilities. The result is a reduction in engine life.